All right, we are in Geometry Lesson 2-5, defining transformation. Today's date is Wednesday, September 30th, 2020. Yeah, so defining transformations, what is our objective for the day? Jade?
By mistakes, students refine definitions of transformations and formally define transformations.
There it is. So the majority of the stuff that you're going to be doing is looking at definitions that someone has made a mistake on and trying to find the mistake. Your main goal today is playing devil's advocate, but very strictly using the rules of mathematics. So let's do example 1. There's a lot of reading there. Does someone want to read that for us? Kira?
Euclid tried to define a reflection. For any point R on the line of reflection L, the image R prime is at the same point as R. For any point P not on the line of reflection L, the image P prime is on the other side of L such that P prime is perpendicular to L. Draw a counterexample to show Euclid's mistake.
Okay. It sounds correct though at first glance, right? If you think of a reflection, that's like a mirroring over. So if you're on the line of reflection, then it's going to be the same point. We can all know it as, yeah. So that's like you're touching the mirror, right? It doesn't really reflect. Okay, what about this one? If you're on the line, the image is going to be on the other side. Of course, yeah, it's going to be on the other side. And the point from the source to the image, or the pre-image to the image, that's going to be a line that's perpendicular. Everything seems good there. So I'll give you guys 2 or 3 minutes. Try to draw a counterexample. I've done these last night, so I know them all, but try drawing a counterexample. How would you do that? Maybe you can visualize it in your head and be like, oh, well, there's clearly a mistake there. There's something missing in Oakley's definition. If you add this one extra thing, then it is the perfect definition of a reflection. But Oakley forgot to mention that. So try to play devil's advocate. How do you poke a hole in Oakley's definition? Who would like to share with a quiet raised hand? Charles.
I think that Oakley needs to add that it's a rigid transformation, so angles and line segments should stay the same.
Angles and line segments should stay the same. So, okay, so how would you draw a counterexample? Using everything here, can you draw something that would use these strict definitions, but then it wouldn't be a reflection? So here, I can draw the line of reflection for you. Let's go ahead and say that that is our L. So if I have, I don't know, do you want to point a shape? What are you trying to do? Okay, let's do a triangle. So if I have that triangle, boom, boom, and I try to reflect it over this line L, it says that it's going to go through it's not on the line of reflection, right? So it's going to go through the line of reflection and be perpendicular. So if I have another line, let's go like this. For example, this point is going to be, it's not going to let me draw that. This point is going to be perpendicular, and it's going to be reflected over here, right? Well, isn't that a reflection still? Okay, so you said that it needs to preserve angles and lengths, and I agree, it is a rigid transformation. But what's wrong with her or his, you don't know, definition? Because it does look like a 90-degree angle. Is it okay if I ask Kira? Yeah, Kira.
Both triangles need to be the same distance from L, or else it's not a reflection.
Oh, okay, so the distance here is not preserved. So you're saying that this point right here, I could move that all the way over here, and that still matches Oakley's definition?
Yeah.
Okay, and I'll let you guys think about this too. This picture right here still works. In fact, Charles was really, really close So I could go ahead and do this. This point over here can be reflected over the line, and I can get a point that looks like this. And it's not, I have to be careful about how I draw. See, yeah, it's reflected over this line. It has a 90-degree angle. I can draw this line. Here, I'll just draw the line first. This point can come, I don't know, right there. All of these points have been reflected with a definition up here. They're all 90-degree angles. I think we can all agree that. I think this line came right there. Look, I reflected all three of these points, and we have this triangle, which definitely did not look the same. All right, and then Kira, so what do we need to add?
I guess you could add something saying like the lengths must be preserved from like the length from line L.
Okay, so the lengths must be preserved. So the lengths must be congruent.
Yeah.
So you can say that the segment from point P, because again we're assuming point P is not on the line, that's how Oakley is defining this, from point P to L is congruent to segment from L to P prime. Once those two line segments are congruent, like if this was congruent to that, then it would have been the correct definition. Asha, question?
So, like what you just said, is that basically saying that point P to the line L has to be the same distance to point P prime?
Say that one more time.
Like, so point P and point P prime have to be equally far away or close to line L.
Exactly, yeah. All right. I'm not sure how well everyone followed that. Give me a quick fist of 5. Does everyone understand what the error was in Oakley's definition? Okay. I don't see any close corners. Let's go on to the next one. Oh, it's almost Charles. I guess, is your formal name actually Charlie?
That's what it
Okay, so your actual name is Charles? Okay. All right, so I need another reader. We'll give it to Jade.
Charlie tried to define a rotation. For the center point C, the image C prime is at the same point as C. For a point P that is not at C, a rotation of
Theta?
theta
Yes.
about point C creates point P prime, such that CP is equal to CP prime, and M equal PCP prime is equal to theta.
All right, thank you. So there's a lot to unpack there. Let's work through it nice and slow. So we have some center of rotation C. If you're on the center of rotation, you're not going to move. That's what this first bullet point is saying, which makes sense. We've seen that before. All right, so there's going to be something wrong with the second bullet point. For a point P that's not on the point of rotation. If you rotate by a certain amount, I'm just figuring here, a rotation of some angle, theta, about point C, that's going to create a new point. So far, so good. Obviously, we're going to have some sort of new point. Okay, such that CP, again, CP is the line, you're trying to think about, I can't draw because it'll give it away. If I draw a line from our original point, our source, our pre-image, to our center of rotation, and I draw another line from the image P back to the center of rotation, which we've done before. That was the tool I told you guys. How do you figure out what the angle of rotation is? You draw those two lines, and then you measure that angle. And say, yeah, that angle should be theta. What's wrong? Okay, question?
What is theta?
Theta is some angle. It could be 60 degrees, it could be 180 degrees, it could be like 79.32. We don't know what angle it is, but it's some angle. So if this angle was 2 degrees, then the angle that it measures should also be 2 degrees. It's the same variable. Why?
So is theta like a variable for angles?
Typically, yeah. There's a lot of other. Typically, we use Greek letters for variables for letters. So sometimes we and usually lowercase. So most typically we'll have theta, then alpha, then beta, and I haven't really seen any others than that. Because once you have 3 angles, you're usually done. Yeah, good question. All right, does everyone understand what I'm asking? Is there any confusion? Okay, if I raise hand, if there's any confusion about what these 2 bullet points are saying, now is a good time to ask. Otherwise, I'm going to go ahead and give you guys some time for here at the Nasha.
What? Like, what is CP?
So, okay, I'll do a really rough sketch to show you guys what's going on. So, if I have some center of rotation, I'll call that point C. Let's choose a random point P. Boom, right there, point P. It's saying, hey, I'm going to rotate by some new amount, such that if I have a point out here, I'll call it P prime. It's saying that if I was to rotate by 100 degrees, then this angle right here should be 100 degrees.
So that's what it's talking about when it says such that CP equals CP prime.
Yeah, so CP, the line segment CP is right here. And this CP prime over here.
So then what is an angle?
So this is saying that the measure of the angle. If I were to measure this angle with a compass, no, protractor, sorry. If I had a protractor out, and maybe I could even pull out my mega protractor that I have in here. If I were to pull out my mega protractor and measure the angle, that's what this is saying. If I measure the angle, I would say, oh yeah, that's 100 degrees. What question?
I think I have a way to counter it.
Okay.
I think.
Are there any more questions on what this is trying to say?
Well, I don't see why it's wrong.
Okay, well, that's fine. So we'll take our time to think. And I drew the case where it works. You have to find a case where it doesn't work.
But if you rotate point P around point C, negative 100 degrees, that angle is still going to be 100 degrees, but negative 100 and 100 aren't the same number. They're 200 apart. So therefore, her explanation is wrong.
Charles, you want to try explaining it a different way?
Well, what I was thinking is maybe theta is just like an example of any angle, but if it was like say x, then it would have to be the same angle. But I wasn't really sure about that.
Yeah, okay, yeah, so yeah, we have to use theta over and over again. So it's not like I can choose 40 degrees and 60 degrees. It's still going to be the same angle, 60 and 60 degrees. Okay, let me try approaching it from a different direction. And I think I'm just going to draw the counterexample for you guys in my explanation. So let me draw that original picture up there. So if I have some point C, and I'm going to start out here with a length of 3 units, so 1, 2, 3. I'm going to call that P. If I rotate that by 90 degrees, I'm going to go ahead and say, let theta equal 90 degrees. So that means I should be rotating, is that counterclockwise or clockwise? A positive 90 degree rotation. Give me clockwise is thumbs up, counterclockwise is thumbs down. Everyone has it, yeah, counterclockwise. So counterclockwise, this direction, 90 degrees, and I come down to this point, P prime, which seems okay. So if I go ahead and do a quick sketch of the line, again, you're always drawing a line from P to C and P prime to C, and I'm going to measure that angle. This angle right here should measure 90 degrees. Here's the counterexample. What if I draw another point over here? I'll call that P prime prime. Sure, P prime prime. This angle right here also measures 90 degrees. But you're saying, wait, Mr. Snell, that's negative 90 degrees. No, look at the definition. It's saying use your protractor and measure P, C, P prime. In this case, it's P double prime. If I pull out this protractor and measure the angle, ignore the red, just look at the green over here. If I measure this angle over here, this angle should be 90 degrees. I don't care about what direction I am. If I'm going counterclockwise or counterclockwise, clockwise or counterclockwise, it's only saying, hey, if the measure right here is the same theta as this original theta, then I've done my work. So this is my counterexample. I don't know which direction I'm going. Direction was not included in the information up here. So that's the mistake. You have to talk about some sort of direction. Always go counterclockwise or always go clockwise. And that was like a super technical and hard definition of all. But I'll also say that was also 90 degrees. So what are we missing? I'll have for the notes. We're missing direction. All right, that was hard. Let me give you a only slightly easier one. It's still kind of hard. Let's go to example number 3. I need another person to read. Ulysses?
Harper tried to define a translation. Point A maps to point A prime. Every point P maps to point P prime, such that P prime is parallel to A prime and points in the same direction as A prime.
Okay. So let's first analyze what's going on here, and then you guys are going to try to make a sketch of a counterexample. Okay, translation. It's another word for move, right? I'm translating from point A to A prime. This first bullet point doesn't even define anything. It's just saying, hey, I'm going to go from A to A prime. Okay, this is kind of the bread and butter here. So every point P maps to point P prime. Again, not really any new information. We have our source and we have our image. Such that if I look at the line that connects P to P prime, technically it's a ray, because that's the way that they define it in their notation. That should be parallel to A prime. So think about that. If I have A prime, that should be parallel to P prime. Does that make sense for a translation? I'll draw a picture in a sec. It points the same direction. Okay, so I can't go backwards. Darn. You already thought of that. Yeah, here.
Why are we even talking about A then? Why are there 2 points?
So he or she, I try to make these gender neutral names. This person, Harper, is defining a translation just by showing that it's parallel. So let's go ahead and see what's going on here. If I draw, I guess I should do it electronically because my counterexample will be right next to it. If I draw a point, let's go ahead and say A is right here. And I'm just going to make it a really easy translation. Let's do 3 units to the right. Oops, right there. 3 units to the right, that's going to be my A prime. So far, so good. I'm translating 3 to the right. I'm also going to have some other point P. And I should be translating that 3 to the right. Again, this is not a counterexample yet. Do you agree that no matter how you do this, maybe I translated 2 right and up 1, 2 right and up 1, these 2 lines should always be parallel. So that's what he or she is saying. PP prime is parallel to AA prime. Not only that, it's also going in the same direction. If I'm going from here to the right, I'm going from here to the right. So that avoids the possibility of going to the left. Because I was thinking, oh man, I could have made a counterexample where I went like this. Oh, if it has to be parallel, then I can go over this direction to get to P prime. Ah, no, I can't, because I have to go to the right. It has direction. Maybe Harper learned from Charlie's mistake where direction was the thing that was missing. So what is the thing that Harper's missing now? So I should write this in the notes too. It looks like more and more hands are getting it. I'll give you guys another 10 seconds and then we'll discuss. This is not a counter example. But there is one that is a counterexample. All right, pair up, or groups of 3 for over here. Talk to a neighbor. Did they get the same counterexample as you? Did they find the same missing information?
Well, I think it's weird because I think that Israel and the revelation of everyone is terrible. But I think it's weird because like how like what you just make random points and things that work. So I didn't get any.
All right, talk to someone new. Rotate a little bit. You can scroll, move around in your chairs.
Yeah.
No, talk to someone else. Are you talking white yet? I don't know. Have you talked to Heshy yet?
They're not parallel, it's like it's going past it.
I should move.
I think the other day was just about said that they weren't like.
Oh, right, they were just the same one.
Let me move this over here. All right, choir raise hand. Who wants to share? I have 2 people again. 3. Ulysses.
I was thinking, like, what if A and A prime, P and P prime are like on the same line, and they won't be further?
Oh yeah, using the definition. That's actually a really good one. Yeah. So if they're on the same line, that would definitely invalidate it. So here's a counterexample. If we put P on here to P prime, judging by Khan Academy's definition, those are not parallel. They are indeed the exact same line. So, and that's one of the things that I don't like about Khan Academy. I consider those 2 to be parallel because they have the same slope. But yeah, I think Khan Academy would say, you're right. Those aren't parallel. Those are the same line. Yeah, that's great. Thank you. And there's another one too. There's another counterexample you can draw. So I'm going to go ahead and give you the check. Yep, that one works. What's another one? I assume if you put your hand down, that means that you found the same one. All right. Jade.
If A prime and P prime weren't array and they were just lines, it'd mean the same thing. But they didn't define that, so they wouldn't be pointing in the same direction.
Say that one more time.
Okay, so A and A prime, because it's array, and P prime is array, they're pointing in the same direction. But if it was a line segment, it wouldn't be pointing in the same direction because it is an array.
So where's the line segment that you're talking about?
If it were just A and A prime.
So I mean, array is always defined by 2 points, A and A prime, and it goes forever and ever past A prime, right? And then if I have P prime, that also defines array, but it can also define a line segment depending on what you're talking about. So I guess I'm a little bit confused on what you're trying to say. Like, it seems like you're kind of picking out a line segment, saying that the line segment disproves it somehow. Okay, maybe say it for the 3rd time. Maybe I'll get it on the 3rd time. Sorry.
Now that I'm like kind of saying that, I'm just like blind in my head.
Okay, I'm sorry. I should have got it after the 2nd time. It's one of those things that they tell teachers you're supposed to listen to, not listen for. I was listening for instead of to, so that's my bad. If you can think about how to say it again, then you can let me know. I'm gonna go with Kira.
Okay, well, I don't know afterwards if this actually works, but what I thought was like A. Well, no, because it doesn't work, because I thought they were line segments, because if they were line segments, and A and A prime like ended way before P and P prime even started.
Yeah, so, yeah, and that's, I think, one of the reasons that they did array. But even if you have line segments, you can still say that the line segment is parallel. No matter how far away you move the line segments, they should still be parallel.
So they're parallel even if one's not like over the other.
Well, yeah, that's what Ulysses was talking about. According to Khan Academy, that isn't parallel. So that would be a valid counterexample according to Khan Academy. For me, in my class, no, I would say that those two lines have the same slope. I just define parallel if it's parallel or not, judging on its slope. So, does anyone else have a counterexample? There's one that I'm looking for. It's one of those things, listing 2 versus 4. All right, let me give it to you. And I have a feeling you guys are going to be like, ah, darn, that was way easier than I thought. Here's my counterexample. I'm going to grab this P prime. So this one, my counterexample, I'm moving 2 to the right. Watch this. Ready? Here's my counterexample. I move 3 to the right. Nowhere in this definition did it say you had to move the same distance.
So
A translation, you definitely need to move the same distance both times. This one is only saying that's parallel, which is great. If I started with 2 parallel lines, yoink, yoink, and I can have one set right there, the other set way over there, and have a giant translation. Distance was not part of the definition. Check the definition again. It's only talking about same direction, being parallel, missing length.
That was all about distance, basically.
Yeah. This one was missing distance. And I guess I could have abbreviated everything up here. This one was also missing distance.
So if they were translated like a different distance, then the rays aren't parallel?
So they're still parallel. Like you can say that A prime, that ray, and P prime, those 2 rays are parallel.
But that's not a translation.
But this is not a translation because this, I mean, yes, it is a translation of 2 units, but this one is a translation of 3 units, which breaks the definition. This should be a perfect translation. Just judging by the definition, I don't know if I'm moving 2 units, 3 units, negative. Well, you can't do -5 through it because that's the wrong direction. They have defined direction as part of the translation. So yeah, it should have said just have A prime congruent to P prime. Those line segments have to be the same distance, congruent. All right. And now this one, I have a feeling that's going to be easier, but I'll actually test this out with you guys. Example number 4. Another reader, please. Esha.
A certain mapping in the xy plane has the following properties. Every point A on the line L maps to itself. Every point P that isn't on L maps to a point P prime, such that P prime is the diameter of a circle centered on L, and P prime is perpendicular to L. What transformation does the mapping define?
There it is. I know that what's being explained here is kind of hard, like circle, like a diameter of the circle. What the heck are they trying to say? But really, if you boil it down, you have 4 options. I've only taught you 4 transformations. You have a 25% chance of getting it correct. Is it a translation? Is it a rotation? Is it a reflection? Or is it a dilation? And hopefully you can throw out 2 right off the bat, like, how can I map to itself if I'm a translation? If I'm a translation, I should be moving somewhere. So that's out of the bag. Now you got a 33% chance of getting it right. Which one makes the most sense between reflection, rotation, and dilation? And again, dilation actually doesn't make sense because it's really hard to map something to itself. No, if you're on the point of dilation, that could work. So maybe that's still in the bag. Okay, still 33% chance of getting it. What's going on here? So I'm going to make everyone guess for this one. Let's go ahead and say a rotation, you're going to hold up 1 finger. A reflection, you'll hold up 2 fingers. A dilation, you'll hold up 3 fingers. Fingers up. And if you want to do a translation, you can do a 4, but I'm not cool enough to do that. Interesting. The majority has it. Let's draw out what's going on. So, we have a line L. It's defined up here. We have a line L. Let's go ahead and make a line L. Yeah, okay. So I have a line L. I'll go ahead and label it. That's line L. Every point on A on the line maps to itself. So if I have a point here, A, it maps to point A prime. Those are the same points. What about the second one? Every point P that isn't on L, so let me draw a point P over here. This point P is not on L, clearly. Maps onto a point P prime such that P prime is the diameter of a circle centered on L. Okay, so I have to have some circle centered on L. Let's try doing one down here. I'm going to say that's the center of my circle. If I were to make a circle, let's see if this works. Let's try to drag this, make it a little bit bigger. This is why I wish I had smart notebooks, so this would be faster. Okay. So point P is on the circle, and the circle is centered at L. So far, so good. Such that P prime is the diameter of the circle. Okay, so we can make the diameter of the circle. Are you guys ready for this? The diameter of the circle is going to look like this. The diameter is the longest point across. Oh, look, it looks like it's going to break the definition, right? This is the diameter of the circle. Oh, but read this last part. And P prime is perpendicular. We have to make this perpendicular. The only way that we can do that is by making the center of the circle come higher up. So if I drag that point out of the way, drag this point right there, drag that line so it's still, okay, I have to move the circle too, don't I? There we go. Make it slightly smaller. Oh, stay a circle. And it needs to be bigger. Yeah, because I should have just kept it the same size. Okay. And now this line, P prime, should be a diameter of the circle. Again, my circle's a little bit off. Looks a little bit better there. And now I have a point over here, P prime, and I've met the definition. That's my P prime. And I can draw my P again.
So what trans?
All right, so now do fingers. Is it a rotation, reflection, or dilation? And it looks like you now unanimously have the correct answer. This is a reflection.
I do not like that.
Yeah, that was
This
weird.
makes no sense. How?
There are some key. Oh yeah, go. Question.
How is that a reflection? Because I thought it was a reflection in the beginning, but then when we did it, I decided I didn't think it was. But I didn't know. I don't know what transformation it is. Well, I know it's a reflection now, but why?
So it's a reflection because I'm going to be perpendicular. So the reflection is basically defined by 2 things, right? It needs to be perpendicular to the line of reflection, and it needs to have the same distance. Well, it's perpendicular because it says perpendicular. Secondly, it's the same distance because if I have a circle, this radius and this radius are the same distance because that is a property of circles. All of the radii, the plural of radius, all of the radii of a circle are all the same length of the circle, and therefore this length and this length are congruent. So we've met both parts just in a weird roundabout way. And again, you don't need to have this down perfectly. You can look for keywords. Like the keyword is a line and perpendicular. Just from those 2 words, line and perpendicular, it's going to be a reflection. You might be looking at the word circle and be like, ooh, circle, rotation. And I can see where you're coming from, but if you draw it out, you should see what you're doing too. All right, I know these are hard, and this is the best lesson I could come up with to teach it. Question what?
So, so my first guess was reflection, which ended up being correct. So my explanation was that the word perpendicular is in there. Would that be correct in saying like it's a reflection because the word perpendicular is in there?
That would be a great indicator. And when I do the quiz and test, I'm not going to be super strict about it, but yeah, I need more than just perpendicular on the test. I need you to be able to draw something out for me. So for the homework, yeah, it's enough to say yeah, because it's perpendicular, but be ready for actually writing this for a free response test and actually write this out. All right. For the final part of this lesson, give me the fist of 5 on our objective. How well do you think that you can find mistakes in student-defined definitions of transformations and also formally defined transformations? I'm seeing 3s, 2s, a 4, mostly 3s. I would say the average is a 3. Yeah. All right, thank you guys.